You ready? Let's learn some math. Math, 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 math. Math, 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 math. Math, 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 math.
Come, take a journey with us each Monday from 5:30 p.m. on ABS TV. Let's get to the heart of the matter. Math matters. Welcome to another episode of Math Matters. I'm your presenter, Tisha Hughes Thornhill, and today we are going to be taking a look at test-taking tips and strategies as it pertains to CSEC Mathematics Paper 2. Before we begin, let's take a look at our practice questions from our previous episode, Test-Taking Tips and Strategies for Paper 1. Our first question reads 0.045 times 10 to the negative 3 in scientific notation. So the options are there, A to D. Which is our answer? So we'll notice that for scientific notation, we would need to have a digit greater than 0 in front of the decimal point. And so we're going to have to move that point until it is between the 4 and the 5. So let's do that. So we just moved a point 2 places to the right. And so this now gives us 4.5 times 10 to the negative 2. But we have to take into consideration the times 10 to the negative 3 that was in the original question. And so what we're going to do is we're going to add those powers. And when we add negative 2 plus negative 3, we get a power of negative 5. And so our answer is therefore B. Question 2. What is the value of the digit 3 in the number 50.736? So we first identify the digit that the question is asking us about. And we will know that based on its location, we can eliminate C and D because the 3 happens to be located after the decimal point. And any digit that follows the decimal point can be written as a fraction. In this case, the 3 is the second digit after the point, and so that answer is going to be A, which is 3 over 100, or 3/100. Question 3, our favorite topic, fractions. So what we have here is 4 2/5 plus 3 1/3. And we're going to add these fractions based on what the question asked us. And I think we should be able to eliminate some of those options based on what we have here, but let's just work out the question. So here we have the question rewritten, and we're actually going to handle the whole numbers first. So we're going to add 4 plus 3. And then we need to focus on the fractional portion. So we're only looking at 2/5 and 1/3. Now we know when we add fractions, we have to find our LCM, or lowest common multiple. So between 5 and 3, our LCM is 15. And so we write that. Now we are in the process of creating equivalent fractions. So what we want to do is to change 2/5 and 1/3 now to have denominators of 15. So 5 times what gives us 15? 5 times 3 gives us 15. And so that means we are going to multiply 2 by 3 as well. And then 3 times what gives us 15? 3 times 5 gives us 15. And so 1 times 5 is what we're going to do there. So 2 times 3 is 6, and 1 times 5 is 5. Now we can go ahead and add the whole numbers, which 4 plus 3 is 7. And we can also add the numerator, which is 6 plus 5, and that gives us 11. And so our final answer is 7 and 11 over 15, which is D. Here we have our final question, question 4. Negative 5 all squared plus negative 2 cubed. Based on the question, which of the options do not fit the question, and how do we know? Well, just from looking at the options, I would eliminate A and B because those numbers are too small based on what we're asked to do, which is to square and to cube a number. Negative 5 squared plus negative 2 cubed. Hopefully, we're remembering that when we square something, it means multiplying that number by itself. Also, cube would be multiplying the number by itself 3 times. So if we were to expand this, it would be negative 5 times negative 5 plus negative 2 times negative 2 times negative 2. Negative 5 times negative 5 is positive 25. And we'll have to put back the plus sign. Negative 2 times negative 2 is positive 4. And times another negative 2 would give us negative 8. So from previous lessons, when those signs come together, that means to subtract. And so, in essence, what we have here is 25 minus 8, and that gives us 17. So our answer is therefore C. Just a note, when we are using a power with a negative number, so for example, squaring negative 5, 2 is a positive number, and so our answer is going to be positive. So if our power was to the 4th power, to the 6th power, etc., the answer, the final answer, is going to be positive. However, if the power is odd, our answer is going to be negative. Let's hear a word from our sponsor. And when we return, we'll take a look at test-taking tips and strategies specific for CSEC Mathematics, Paper 2.
The Board of Education is responsible for the funding of scholarships, awards, and bursaries within Antigua and Barbuda. In keeping with our mandate, interested individuals who are citizens or nationals of Antigua and Barbuda are invited to apply. Application forms are available online at www.abboardofeducation.com and should be completed and submitted on or before the last working day in April of each year. Scholarships are available for those wishing to pursue an associate's, bachelor's, or master's degree locally, regionally, and internationally. Individuals reading for PhDs are also supported. We are the Board of Education. For more information, visit our website at www.abboardofeducation.com or call us today at 463-9025, 463-9026, 463-9027, or 463-9028.
Welcome back. As mentioned before, we are going to now take a look at test-taking tips and strategies specific to Paper 2. Some very important information is going to be mentioned to keep in mind when tackling this paper. First, here's the date. Monday, May 13th, and the exam is only allotted 2 hours and 40 minutes. As you notice, this time is fast approaching, and so hopefully this episode will help you in preparing for your exam. Another thing to note here is that this exam is a morning exam, which means the exam starts at 9 a.m. So be sure to be at the center at least an hour before. As you go through the examination, be mindful of the time, as you will only have about 16 minutes per question. So use your time wisely. Calculators are permitted on this exam, and a formula sheet is provided. This exam is worth 50% of your overall grade. The paper consists of 10 multi-part questions, which are compulsory, and is worth 100 marks overall. This is broken into 3 parts. 30% focuses on knowledge, which is what you can recall. 40% on comprehension, or how you can apply what you've learned. And the final 30% focuses on reasoning, which is using what you've learned to solve real-world problems. This exam covers the entire syllabus. So let's look at specific topics. The content areas to be covered in Paper 2 happens to represent the entire syllabus. It is therefore important to thoroughly prepare and not take any topic for granted. The topics are as follows: number theory and computation, consumer arithmetic, measurement, statistics, algebra, relations, functions and graphs, geometry and trigonometry, and vectors and matrices. Please keep in mind that each topic is equally important, so be sure to familiarize yourself with each of them. Here we have the cover page of an exam. The exam cover sheet includes the time allotted, specific instructions which should be read carefully, and at the bottom has required examination materials, and those include an electronic calculator and a geometry set. Now let's look at specific test-taking tips for this paper. When taking the exam, read the instructions and questions carefully. Make sure you understand what is being asked in order to begin to answer. It is also important to answer what you are asked. Do not do any unnecessary work, as this may cause you to waste time. Observe possible marks for each part of the question to guide how detailed your response needs to be. It is important to know your mathematics vocabulary. Without this knowledge, it may be difficult to know what exactly is required of you. For example, if the question mentions multiplicative inverse, gradient, or even factorize, would you know what those terms mean? Answer all questions. It would not be wise for you to leave anything blank, even if you are uncertain if what you have is correct. Partial marks may be awarded for what you've written. Be sure to show your working or thought process. Students often believe, since they're using calculators, that working cannot be shown. Whatever is put into the calculator should be recorded. It is always recommended to check over your work. Maybe even triple check your work if time permits. Finally, it is very important for you to stay calm. Nerves can cause you to forget what you've learned and have been practicing. You may even overthink what is being asked, frustrate yourself unnecessarily, and lose track of time. Following are some things to consider when preparing for Paper 2. To be successful on this paper, it is important to work on problem solving. The steps to problem solving include asking yourself, What do you want to know? What do you already know? What can you do? And how do you know if you are correct? I'm sure you've heard practice makes perfect. Practice, practice, practice. Mastering math is all about practice. It is recommended you identify your weak areas and work on them. Finally, it is very important to get enough rest, especially the night before the exam. We would have touched on some important considerations for paper 2. Please keep them in mind as you prepare for May 13th, which is approaching very quickly. We'll be right back after this short commercial break, and when we return, we are going to zoom in specifically on patterns and sequences.
The Board of Education is responsible for the funding of scholarships, awards, and bursaries within Antigua and Barbuda. In keeping with our mandate, interested individuals who are citizens or nationals of Antigua and Barbuda are invited to apply. Application forms are available online at www.abboardofelucation.com and should be completed and submitted on or before the last working day in April of each year. Scholarships are available for those wishing to pursue an associate's, bachelor's, or master's degree locally, regionally, and internationally. Individuals reading for PhDs are also supported. We are the Board of Education. For more information, visit our website at www.abboardofelucation.com or call us today at 463-9025, 463-9026, 463-9027, or 463-9028.
Welcome back. For our question today, we are going to be looking at patterns and sequences. There are many different sequences and patterns in mathematics. Let's take a look at some. The first pattern we're going to be looking at today is arithmetic sequence. This pattern is also known as the algebraic pattern. It is a sequence of numbers based on addition or subtraction to form a sequence of numbers that are related to each other. If two or more numbers in the sequence are given, we can use addition or subtraction to find the arithmetic pattern. Another pattern is called or known as the geometric pattern or sequence. This is a sequence of numbers that are based on multiplication and division. If two or more numbers in the sequence are provided, we can easily find the unknown numbers in the pattern using multiplication and division operations. The Fibonacci sequence is a pattern of numbers in which each number in the sequence is obtained by adding the two previous numbers together. The sequence starts with 0 and 1. Observe this Fibonacci sequence: 0, 1, 1, 2, 3, 5, 8, 13, and so on. Here we can see the pattern that is followed is 0 plus 1 equals 1, 1 plus 1 equals 2, 1 plus 2 equals 3, 2 plus 3 equals 5, and 3 plus 5 equals 8. And of course, it keeps going. Our fourth pattern is the triangular number sequence. This is the representation of the numbers that can be arranged in the form of an equilateral triangle, arranged in a series or sequence. Here is another pattern arrangement representing triangular numbers. These numbers are in a sequence of 1, 3, 6, 10, 15, and so on. Our fifth pattern is a square number sequence. The square number sequence is the representation of the numbers in the form of a square arranged in a series or sequence. A square number sequence may also be represented in the form of a triangle, as seen on the screen. When we multiply an integer by itself, the approaching resulting product is called a square number. So, 0, 1, 4, 9, 16, and 25, and so on are all square numbers. Let's take a break and hear a word from our sponsor. And when we return, we're going to take a look at specific CSEC type questions.
The Board of Education is responsible for the funding of scholarships, awards, and bursaries within Antigua and Barbuda. In keeping with our mandate, interested individuals who are citizens or nationals of Antigua and Barbuda are invited to apply. Application forms are available online at www.abboardofelucation.com and should be completed and submitted on or before the last working day in April of each year. Scholarships are available for those wishing to pursue an associate's, bachelor's, or master's degree locally, regionally, and internationally. Individuals reading for PhDs are also supported. We are the Board of Education. For more information, visit our website at www.abboardofelucation.com or call us today at 463-9025, 463-9026, 463-9027, or 463-9028.
Welcome back. Now that we've explored various types of patterns in mathematics, let's take a look at CSEC type questions. As we go through the questions to create a complete pattern, there are a set of rules to be considered. To apply the rule, we need to understand the nature of the sequence and the difference between the two successive numbers. It takes some amount of guesswork and checking to see whether the rule works throughout the whole series. Question 1. A sequence of figures is made from joining polygons with sides of unit length. The first 3 figures in the sequence are shown below. The question wants us to draw figure 4 of the sequence. So as we take note of figure 1, figure 2, and figure 3, we'll see that we keep adding another polygon, or in the case of the question as it was stated, joining polygons with sides of unit length. We'll also note that as the polygons are being joined, the right corner or end is now broken. So figure 4 would look like this. And we want to be sure that when we are drawing our figures, that we are utilizing the appropriate tools, and in this case, a ruler would be necessary. Part B of that question. Study the pattern of numbers in each row of the table. Each row relates to one of the figures in the sequence of the previous figures. And here we have just a caption of what we would have previously drawn and the figures that were given to us. Some rows have not been included in the table. Complete the missing rows in the table. So let's begin by assessing what we have already in our table. Well, I see 3 columns, and the first column gives the figure, the specific figure number. The second column is the number of outer lines of unit length, and the third column is the perimeter. So when we look at the first row under the number of outer lines, the second column, we notice that we have 1 plus 2, and then we have plus 2. So we'll come back and maybe discuss why those are looking the way they are. We'll also see for figure 2 that we have 2 plus 2 plus 4. So if we look at the first row, figure 1, and the second figure, we'll notice that the first digit seems to be the figure number, and the second digit is consistent. But then the third digit, which is circled, we have 2 and 4. Well, let's see if we can come up with how those came about. Let's look at the third one. 3 plus 2 plus 6. So from assessing this pattern, I think it's fair to say that, okay, the middle digit is consistent. The first digit is the pattern, or the figure number. And then the third digit would be, or would come about, if I multiply the first 2 digits. So 1 times 2 gives me 2, 2 times 2 gives me 4, and 3 times 2 gives me 6. And so I think from that, we should be able to fill in the first blank for figure 6. So following that pattern, our first digit is going to be 6 because that represents the figure number. And the second number is going to be 2 since that's the constant. And then the third number is going to be 12 since we multiply 6 times 2 and it gives us 12. In order for us to get our next blank spot in or pertaining to figure 6 on the perimeter, we'll now note that in order for us to get those perimeters, it was just a matter of adding the number of outer lines with the unit length. So if we add 6 plus 2 plus 12, we get 20. And we can even go back and check. Figure 1, 1 plus 2 is 3 plus 2 is 5. Figure 2, 2 plus 2 plus 4 gives us 8. Figure 3, 3 plus 2 plus 6 gives us 11. And so we know that what we would have done there is also true and correct. But when we look at the next 2 blank spaces, we see that the perimeter is what was given. But it's not necessarily easy to see a connection in the reverse. And so the recommendation would be to skip and go to the final row, which asks about the nth figure. Because once we know what the nth figure should look like, then we should be able to do anything else in the reverse. So looking at n, for the first blank spot in the second column, we will notice that, well, we said the first digit represented the figure number, which in this case is n. The second number was a constant, which is 2, so we're adding 2. And then the third number was 2 times the figure number. So we can now replace what we would have done with the respective n filling those spaces because it's supposed to work for any figure number. So our result here is n plus 2 plus 2n, just from following the pattern. So we can also make this connection to find the perimeter answer for the nth term by looking at the perimeter column and going vertically. So when we look at 5 and 8, we will notice that it is a difference of 3. And so 5 plus 3 gives me 8. I can also connect 8 to 11 by adding 3 to 8. We can test this out because now we're thinking that from this addition of 3 coming down vertically, it would be safe for me to multiply the nth term by 3, which means the figure. So if I multiply figure 1 by 3, I get 3, but I don't get 5. How do I get 5? If I add 2, I can get 5. So let's see, because if it works for figure 1 and it's supposed to be true, then it should work for figure 2 and figure 3 as well. So let's test it on 2 and 3. 3 times 2 is 6, and we're now saying we'd add 2. 6 plus 2 gives me 8. Figure 3, 3 times 3 is 9, and 9 plus 2 gives me 11. And so I can just now say that for the nth term on the perimeter, it is 3n plus 2. But like we previously said, because the second column is also connected to the third column, we could have just simplified that addition statement there. So n plus 2 plus 2n is also equal to 3n plus 2. But because of the format in which the middle column is stated, we would need to keep that form of n plus 2 plus 2n. Now that we have that information, it would be much easier for us to work backwards, given a perimeter of 65, to finding the figure number and also the number of outer lines of unit length. So what we would use, since the perimeter is 65, we would use what we have for perimeter, which is 3n plus 2, and we would set it equal to 65. Now this is a linear equation. And so what we need to do is to solve for n, because that would give us our figure number. Now we know from our previous lessons and from practice that we would start with minusing 2 since 2 was being added. And what we do to one side, we must do to the other side. So if we rewrite this equation, it now becomes 3n is equal to 63, because 65 minus 2 is 63. Now we have 3n is equal to 63, and that is an example of multiplication. So we need to get rid of 3, and to get rid of multiplication, we do the opposite, which is division. And so we're going to divide both sides by 3. From that, 63 divided by 3 is equal to 21. And so n is equal to 21. So this now tells us that when the perimeter is 65, we're talking about figure 21. And of course, it would be easy for us to fill in the middle column because, well, following our pattern, n is 21. So we'll have 21 plus 2 plus 42, because 2 times 21 is 42. Part C of the question asks us to show that no figure can have a perimeter of 100 units. Now, it's going to be a similar process like what we would have done previously, which would be using the nth term for the perimeter and setting it equal to 100. So let's work that out. 3n plus 2 is equal to 100. So we'll follow a similar process. So a minus 2 on both sides, and that gives us 3n is equal to 98. And then we'll divide both sides by 3. When we divide both sides by 3, we'll notice that 3 into 98 does not give us a whole number. The answer is in fact 32 and 2/3. And so we can't have a figure 32 and 2/3. So this proves or shows that no figure can have a perimeter of 100 units. Let's pause for a moment to hear a word from our sponsor.
The Board of Education is responsible for the funding of scholarships, awards, and bursaries within Antigua and Barbuda. In keeping with our mandate, interested individuals who are citizens or nationals of Antigua and Barbuda are invited to apply. Application forms are available online at www.abboardofeducation.com and should be completed and submitted on or before the last working day in April of each year. Scholarships are available for those wishing to pursue an associate's, bachelor's, or master's degree locally, regionally, and internationally. Individuals reading for PhDs are also supported. We are the Board of Education. For more information, visit our website at www.abboardofeducation.com or call us today at 463-9025, 463-9026, 463-9027, or 463-9028.
Welcome back. Let's take a look at a different type of pattern question. Question 2. The first 8 terms of a sequence with nth term, u of n, are 1, 1, 2, 3, 5, 8, 13, and 21, where u of 1 is equal to 1, u of 2 is equal to 1, and u of n is equal to u of n minus 1 plus u of n minus 2, for n is greater than or equal to 3. For example, the 5th and 7th terms are u of 5 is equal to u of 4 plus u of 3, which is equal to 3 plus 2, which is 5. And u of 7 is equal to u of 6 plus u of 5, and that's equal to 8 plus 5, which is 13. Now, when we look at the pattern, before going to the question, when we look at the pattern, we'll notice that if we use u of 5, they would have given us a resulting answer. So u of 1 and u of 2 were already given. But where did they get 3 plus 2? So the 3 and the 2, that refers to the terms in the pattern. So the first term in the pattern is 1, the second term is 1, the third term is 2, and the fourth term is 3. And so where it says u of 4, that's the fourth term in the pattern, which is 3, and u of 3 is the third term in the pattern, which is 2. And so those are the numbers that we see there in a different color that we will need to utilize when solving this pattern. So let's look at the question. Part A. Write down the next 2 terms in the sequence. That is u of 9 and u of 10. So there in the broken text box, we have a reminder of the important information from the left side, which is in order for us to find any part of the sequence, it is equal to n minus 1 plus u of n minus 2. So for u of 9, that's going to be equal to u of 8 plus u of 7. And when we look for the 8th term in the pattern, which they told us there are 8 terms in the sequence there, the 8th term is 21 and the 7th term is 13. And so that would be 21 plus 13, which gives us 34. U of 10 is going to be equal to u of 9 plus u of 8. So u of 9 is what we would have just found, which is 34. And u of 8 is the last number in the sequence as was given, which is 21. So 34 plus 21 is equal to 55. Let's look at part B. Which term in the sequence is the sum of u of 18 and u of 19? Well, we know that based on the information that we were given, u of n is equal to u of n minus 1 plus u of n minus 2. So when we look at u of 18 and 19, that tells us that it has to be u of 20, because u of 20 would be equal to u of 19 plus U of 18, and that's based on the information that was given. And the final part of question 2. Show that U of 20 minus U of 19 is equal to U of 19 minus U of 17. So given a question like this, what we'll need to do is to expand, in this case, the left side to see if it's going to be equal to the right side. Well, they already told us it's equal. They want us to show that it's equal. So we're going to expand the left side since U of 20 is greater, and we know that we can break that into 19 and 18. So let's do that. So U of 20 would be equal to U of 19 plus U of 18. Then it says minus U of 19. And U19 is U of 18 plus U of 17. And so we will need to get rid of those square brackets, but they're separated by a subtraction sign. And just like in algebra, the subtraction sign would have to be distributed to each part that is in the bracket. So that subtraction sign is going to be distributed to U of 18 and U of 17. And so we can rewrite the left side without the brackets, the square brackets, and distribute the minus sign. So negative times positive is negative. So that leaves U of 18 and U of 17 as negatives. And we also know that if we have a positive U of 18 and we subtract U of 18, that gives us 0. So those disappear. So what do we have left on the left-hand side? Well, U of 19 minus U of 17. And it is, in fact, equal to the right-hand side. And so we would have gone through the process to show that U of 20 minus U of 19 is equal to U of 19 minus U of 17. This concludes our question. Just to recap some of the tips in a concise manner, we want to remember that one of the final tips that we were given was to remain calm. And so we want to carefully read instructions and questions. Always check your work and answer all questions. Look for important information and terms in the questions. And finally, master your math vocabulary. Always remain calm. Thank you so much for tuning in to another episode of Math Matters. I'm your presenter, Mrs. Tisha Hughes Thornhill. Prizes for the participation in the challenge questions will be announced at the end of the season. However, this episode is our final episode for the secondary portion of Math Matters. Beginning next week, the primary portion will commence with your facilitators, Mrs. Shoya Hurst and Miss Shaka Grant. Thank you so much and have a great evening.